Well, hello again, and welcome to the videos for Shaughnessy's class. This is Exponents and Logs, Lesson 5. Once again, the standard disclaimer, please make sure that you show up to class because we go through it in a little more detail there. But otherwise, this is Lesson 5, and this is on graphical solutions to an equation. Okay. Now, what we do here is we use a calculator, so you do need a graphing calculator to make this work. And a graphical solution. Okay, graphical solutions can be done for anything. All we need to do is sketch the graphs, find the crossing point or the intersection point, and the x-coordinate to that is the solution. And so we can use it to solve basically anything. And on the TI-8384, these are the processes. If you have a different calculator, which I'm not sure if anybody does, but if you have a different calculator, process is different. But on the 8384, you sketch each. You use the y equals. One side is y1, one side is y2. And by side, I mean the side of the equal sign. The left is y1, the right is y2, or vice versa. It really, truly doesn't matter. But you have to do one side is this, one side is that. Then you've got to use the graphing feature and use what you know about the graphs and the functions and all that sort of thing in order to figure out a window setting that shows that crossing point. Then from there you get the calculator to determine the intersection point. Okay. Now when you're showing your work, and that's this, and it's justified against the right, you write out each equation. So you have to write them out. You have to tell whoever's marking your paper or your test that these are the two functions or two equations that I wrote or I graphed. You have to write out an appropriate window setting. You have to write out a description. Now I use a canned description. I use the calculator to determine the intersection point. The x-coordinate is the solution. I just do the same thing every time because it encompasses everything. You can describe it however you want. Be careful not to go just on and on and on and on and on. And then after that, the biggest thing that I've noticed is after people do steps 1, 2, and 3, they forget to give me the answer. So don't forget to give me the answer. Okay? Now you can do this, okay, for any equation. Okay? So solve. Now if I start with just a basic equation, for example, something that maybe I did in junior high, I could solve something like this. Now this is a junior high style thing. Solve 2x plus 4 minus 3 equals 6x. Okay, and I got to solve this. Now you know you did this in junior high. You did lots of these sorts of things. But what I'm going to do is I'm going to sketch y1 equals 2 bracket x plus 4 close bracket minus 3. And I'm going to sketch y2 equals 6x. And I'm just going to type that in, basically left side, right side. And once again, really doesn't matter which is which. So I go into my calculator, okay, and I turn it on, obviously, clean it up, whatever's here. And I go y1, okay, and y1 equals 2 bracket x plus 4 minus 3. And then I go from there and I do 6x. Okay. And what I want to do is I want to sketch this. Now for most of you, to start with, it'll be the standard window. And the first thing you want to do is try to do that. Okay. So mine I've played with quite a bit, so I'm just going to zoom to the standard window. Zoom, which is this button here, and choose option 6, Z standard. And there's the standard window. There's one graph. There's the other graph. And the first thing I do is I ask myself, on the standard window, can I see the solution? Okay, it's not always the standard window. Can I see the solution? Can I see the crossing point? And yes, I can see it. It's right about there. Okay, that's where the two graphs cross. So this window's good. And I'm going to show you what it means when it's not good. Okay, so what I need to do is I need to state my window. Now, there's kind of a process to state window. It's easy. The X's are, you just push window. Okay. The x's are from -10 to 10 with a tick mark at 1. So you just do from -10 to 10, tick mark of 1. That's all you have to do. That's the easiest way to state the window. And then your y's, same thing, negative 10 to 10 with a tick mark at 1. Okay, so you've got that. Okay, so there's how I state the window. Now, if I have to move the window, I have to move the window. We'll get there in just a moment. Next, I have a description, and my description is as what I said. I used my calculator to determine the intersection point. That's a math term, and that's what I'm finding. So you need that. Intersection point. The x-coordinate, and I should write x-coord, is the solution. Okay. I used my calculator to determine the intersection point. The x-coordinate is the solution. Geez, when I look at it on screen, it's not very neat. I apologize for my messy writing. So then from there, looking back at the graph, there's the graph. I need the calculator to figure out the coordinates of that point. To do that, okay, push the second button, and you want this calc, because you want to calculate something on the graph. So second calc or second trace. And you want the intersection point. Well, the intersection point is option 5. So you choose the intersection point, okay, and if you can see it, you're just able to hit enter, enter, enter. Okay, it asks you 3 questions. If you can't see it, then you got to fix the window. It finds the intersection point. The intersection point has x equals 1.25. It does have a y coordinate, but the x coordinate is the solution. So it tells me that if I did the algebra, I would get that x equals 1.25. And there's my solution. Okay? So you go through, you do that. Now, when you're finding out the intersection point, putting a little bit of notes back up over here, when you're finding the intersection point, I'm just going to put it here. Okay? What do? You push the second button. Okay? Then you push the trace calc button. Okay, trace calc, which is up at the top, and then from there you choose option 5 for intersect. Okay, that's what you do. Second trace 5. Okay, but don't say that in your description because that's specific to your calculator. I don't know whether you're using a TI or whether you're using a Sharp or an HP. There are different calculator steps depending on which calculator you use. So from there, all that changes is I just change the equations. Okay, I can give you interesting ones like so. Okay, I could say I want you to solve this equation, and I could give you e.g. solve, and it's going to be x cubed plus 8 equals 6x plus 25. Okay, this is a pretty long equation, and I could solve this. In fact, we can't do this algebraically, at least not in Math 30-2. In fact, you probably couldn't do this algebraically no matter what in high school because we don't have any ability to factor this. But nonetheless, what I do, I sketch one side as y1. So y1 is going to be x cubed plus 8. y2 is going to be 6x plus 25. Okay. I have my window. Now the first thing I got to do is check to see can I see it. So push y equals, clear out what's there. I've got stuff from the last question there. So I clear out what's there and I'm going to put in x to the power of 3 cubed, okay, plus 8. Okay. And the next one I'm going to do is 6x plus 25. And I graph this. Now it's again on my standard window. There's one. And the other one's there. And I ask myself, can I see them cross? The answer is no, I can't see them cross. I ask myself, where can I see them cross? Okay? So if I imagine them going down this way, okay, I'm going to either see them left, right, up, or down from this. If I imagine them going down, they're not getting closer together. It looks like they're getting further apart. But if I imagine them going straight up, it looks like they, might get closer together because this one's turning and going straight up like that. So I need to go up. I need to move this spot up. Now this here is my y max. This is the y maximum. I need to make it bigger. So I need to make it how big? So I take a look at my window. Currently my y max is positive 10. Okay. I need to make it bigger. I could make it 20. I'm going to make it 50. Okay. I'm making it quite a bit bigger. I want to see what happens. Don't go to like 50,000. That's not necessarily helpful. Okay, so I'm just going to go to 50 and I'm going to say, okay, so here's one graph. Here's the other graph. And I ask myself, can I see them cross? The answer here, yes. I can see them cross. They cross here. How did I know 50? Honestly, I didn't. Okay, I kind of guessed, but I didn't. Okay, I just chose 50 and I was going to go from there. And then I might double it to go to 100. And I'm using what I see in front of me to kind of guess, well, where is this going to go? So since I can see them cross, I'm going to copy down that window. So x colon, okay, I push window. It's from negative 10 to 10 by 1. And my y's have changed. It is from negative 10 to 50 by 1. Okay, you don't ever have to change the y scale. You can if you want, but you don't have to. Next, I need my description. So that is the canned description. I used my calculator to determine the intersection point the x-coordinate is the solution. Okay, so I've got my little canned sentence, and then from there I just use my calculator. Remember, it's second trace. Okay, whoops. Second trace, choose 5 for intersection, enter, 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 if you can see the cross, and it tells me my answer, x equals 3.3319776, da 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 da. Now that's an approximate. It's not dead on because it goes on for a while, or maybe goes on indefinitely. But I know at least this much: 3319776. Dot dot dot. Okay, and that's my solution. Now from there you can solve virtually anything. Okay. Doing this, you can solve any sort of particular function. I can give you one that's exponential. So if I give you one like this, and we did something like this before, 13 equals 5 to the power of x, and I need to solve x. Okay. So I'm going to sketch y1 equals 13, y2 equals 5 to the power of x. I go put that in my calculator. So here, clear out what's there. Okay, y1 is 13, y2 is 5 to the power of x. Okay, and I'm looking at my standard window, so I'm going to go back to it first. And here are the two functions. I don't see them cross. Why don't I see them cross? Well, hopefully you know that this is a straight line here. y1 equals 13 is a straight line when y is 13, so it's just up here somewhere. Okay, so I got to move it up a little bit further. I'm using what I know of the functions. So y1 is 13, so I'm going to move my window up. I'm going to move it up again. How far, I ask myself? Well, I need to get up to at least 13, so I'm going to go to 50. And then I'm going to see, do I see them cross? Look at that again. And whoop, yep, I do. Okay. So now I take this window, copy down the window from negative 10 to 10 by 1. And my y window is from negative 10 to 15 by 1. You can do all sorts of things if you want. I used my little canned sentence. And this gets tiring to write out if you're doing multiple graphical solutions, but it's the same thing. I used my calculator to find the intersection point the x-coordinate is the solution. Okay, And then from there, I just go put my calculator back, second, calc or trace, choose option 5 for intersect, enter, enter, enter. Tells me x is 1.5936926. Now that's again an approximation. Okay, it's more accurate than that. 36926 dot dot dot. There's my solution. So I've been able to find the solution for this equation. And it doesn't matter whether this is just an equation that's just in general at random, or it doesn't matter whether I give you a context. Okay. So if I look at this last one here, okay, whoops, the population of a town, okay, so the population of a town is modeled by the equation, just trying to get it, there we go, population of a town P is modeled by the equation P equals 47,368 times 1.047 to the power of x, where x is the number of years after 2000. In what year did the population, or I guess did the population, will the population first reach 75,000? So I'm looking at this equation, and I'm just going to rewrite it here for a second. I've got P equals 47,368 times 1.047 to the power of x. And it wants the population to be 75,000. So I know I've got 75,000 is the P. And it equals 47,368 times 1.047 to the power of x. Now I could do this algebraically, and then honestly I'd prefer it if you did. But if you can't, or if you just kind of don't want to, you can look at this and say, okay, I need to do a solution for this equation. So I'm going to do y1 equals 75,000. I'm going to do y2 equals 47,368, open bracket, 1.047, close bracket, to the power of x. So I'm going to go into my calculator, clear out what's there. Okay. So y equals, clear out what's there. y1 is 75,000. y2 is 47,368 times 1.047 to the power of x. And I could look at this on my standard window. Now I'm not going to see anything. Okay? You're going to wonder, oh my goodness, what's going on? Well, you have to keep in mind, first off, this one here is at 75,000. It's at a y value of 75,000. The last one we did was a y value of 13. It was up here. A y value of 75,000 is way off the screen. It's way up there. So I need to change my y max to 75,000 at least. So I'm going to go through and I'm going to change my y max to 80,000. Okay, because I need to get to at least 75,000 in order to see it. Now if I graph this again, there's the 75,000 line. Okay. Here comes this exponential. This is the population of the town. Can I see them cross? Kind of, just barely. I'm going to move it just a little bit further over. Okay? So moving it a little bit further over, this is my x max. Okay? My x max is this line. So I'm going to move it just a little bit further over. So I'm going to go back to my graphing calculator and I'm going to change it to an x max of 15. Make it just a little bit larger. It was 10. A little bit larger is 15. Okay, and I'm going to take a look. Now you'll notice the graph seems to have stretched a little bit further to the right. And I look at this, and now I can most definitely see the cross. I can see it go through. So this window works. So then I go through and I copy out the window. Okay, so my window is from negative 10. My x is from negative 10 to 15. By 1, and my y window is from negative 10 to 80,000 by 1. Okay. Now from there, my canned sentence, I used my calculator to determine the intersection point period. The x-coordinate is the solution. From there, go back to my calculator, second trace or calc, choose 5 for intersect, enter, 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 and you work it out, and it's going to be 10.0. So I kind of could see it, okay? 0.005,485. So that's what x is. X is the number of years after 2000. It's 10.00 years after 2000. In what year? 2010. Okay, it happened in the year 2010. Okay, so you've got that. Okay, it was 10 years after 2000, 2010. This is a graphical solution. In theory, you can do it for anything. I do need you to know the algebra, but the graphical solution is really, really powerful. If you have any questions, come see me in class, and otherwise, have a great day.